So today I am going to discuss this phasor groups and to draw the phasor groups of three-phase transformers, we need to follow certain conditions that I have discussed in the last class, but I am going to show you those conditions once again. So here are the conditions that needs to be followed. That is, uppercase letters are used to denote the high voltage terminals, and lowercase letters are used to denote the low voltage winding terminals. Next, the 6 coils uh, will be there in case of normal star star or delta delta or star delta or delta star connection. For zigzag connection, we will be requiring 9 coils. The voltage, phase voltage of any particular phase for both high voltage side winding and low voltage side winding will be in phase. High voltage side winding will be assumed as the primary winding and low voltage side as the secondary winding, and the position of high voltage terminals A2, B2, C2 that remains fixed, and they will lie in the top, bottom right and left bottom left corners respectively of some equilateral triangle. Okay, A2, B2, C2, and the polarities will be instantaneous polarities will be same for all the windings. That means if for uh, at any instant of time, if capital A2 terminals of high voltage side winding is positive, then small A2 terminal will be positive for the low voltage side winding, and so on. Okay, so these conditions are required to be followed to draw the phasor groups of three-phase transformers. So there are 4 groups in your syllabus, and these are group number 1, 0 degree phase displacement group, and the possible connections are YY0, DD0, DZ0, that is star star with same voltage, same phase angle, delta delta, same phase angle, delta interstar or delta zigzag. Okay, so 0 degree phase displacement means the phase angle between line EMFs is 0 for any uh, corresponding line EMFs. So if we consider VAB, V capital AV for high voltage side, then the
Hello,
line
sir.
EMF, yes,
Sir,
yes,
can you
yes.
explain about the line voltage and phase voltage?
This I have discussed in last class. Have you attended?
Yes, sir. I have
So what
attended,
is your
sir. Not
problem?
good.
Tell me what is your problem.
Sir, explain
Line
about the
voltage,
line
the
voltage.
concept, the concept of line voltage and phase voltage were taught in basic electrical. What do you want to know? Tell me clearly. Hello.
Sir, difference between the line voltage and phase voltage, sir.
Go through your basic electrical notes and my previous day's class. That is your
Yes, sir.
duty. So in case of 0 degree phase displacement group, the phase angle between, suppose VAB for high voltage side and V small ab for low voltage side, these two EMFs will be in same phase. Similarly, VBC and V small bc will be in same phase, and also for VCA and V small ca, they will be in same phase. Okay. So here the similar phases are placed on the same limb of the transformer. Suppose A phase and small a phase, they are wounded on the side limb of the transformer. So since they are placed on the same limb, so angle between VA phase and V small a phase are always same, always 0. They are in phase. Similarly for B phase and C phase. So these things you have to remember while drawing the phasor groups or connections. Okay. So first of all, let us consider the simplest one, YY0. That means both high voltage side and low voltage side are connected in star, and the line EMFs will have 0 degree phase angle. Okay. So first of all, we have to draw the A phase, B phase and C phase. And see, this is the imaginary equilateral triangle and the vertices are A2, B2, C2. This remains fixed for all connections, whatever may be the connection, star, delta, whatever. This position of this A2, B2 remains fixed. Okay. So here, since the high voltage side is in star connection, so we can draw A2 along this vertical direction, then B2 making an angle of 120 degree with this A phase. So this is A phase, this is B phase and this is C phase. So all these angles are 120 degree. So here the all the 1 points are connected together to get the neutral point. Now this is the primary connection or high voltage side connection. Now to have 0 degree phase displacement, this line EMF VA2 B2 will be in same phase with V small a2 small b2. Similarly for V B2C2 will be in same phase with V small b2 small c2, and also for this one. Okay. So how to make that? So first of all, draw this reference line. So this is the reference line which will be same for the low voltage side also. So this line and this line are in parallel. Okay. Now this point will be small b2, this point will be small c2, and somewhere here will be small a2. So how to make that? So here the phase voltages must be drawn parallel to each other. So since this is A2 and this is A2, that means they are having same polarity also as per our assumption. So we have to draw a this A phase, low voltage A phase parallel to high voltage side A phase. So here we have to draw A phase. Okay. So see, this is B phase drawn parallel to B phase of uh, high voltage side. Then draw C2, C phase which is also drawn parallel to C phase of high voltage side, and then draw A phase. So this is A phase of low voltage side, this is B phase of high voltage side, and this is C phase of low voltage side. So A, B, C for low voltage sides, all the phases are parallel. So phase voltages are parallel. So this is A phase for high voltage side, this is A phase for low voltage side. They are parallel. That means they are in same phase. And for YY0 connection, the line EMFs, this one, that means this line and this line are parallel, and this line parallel, and if you draw this line, then this line and this line are parallel, which makes this YY0 connection phasor diagram. Okay, so based on this phasor diagram, you have to draw the connection diagram. So you will have 6 coils for 3 phases. So these are given 6 coils, capital A1, capital A2, A phase of high voltage side, this is B phase of high voltage side, this is C phase of high voltage side, and these are the 3 phase windings for low voltage side. So this winding and this winding are placed on one leg, this winding and this winding are placed on another leg, and this winding and this winding are placed on the third leg. Okay. Now from the phasor diagram we can see that phasors are directed from this point to the vertices of the equilateral triangle. Okay, so here all the 1 terminals are shorted, so we have to short all the 1 terminals. Okay, in case of low voltage side, all the 1 terminals are shorted. Then we have to draw the neutral point or take the neutral point. Now here in case of high voltage side, these A2, B2, C2, these are the inputs. So we have to draw the 3 input lines A2, B2, C2, and if we require, then we have to draw the neutral also. And these are input for high voltage side, and these are output for low voltage side, because here low voltage side is the secondary side, which is the output side. So this is output side for low voltage side. So A2, B2, C2 are the output terminals of secondary side, and capital A2, capital B2, capital C2 are the inputs to the high voltage side, because this is the primary and this is the secondary. Okay, now you have to draw the neutral line if you require. So this is the phasor diagram and corresponding connection diagram. Any question? Anyone having any question?
No, sir.
No, sir.
Okay, next group is YY6. So Y connection will be same as that of previous one. Now what will be the secondary connection? Now before connecting the secondary side, if you excite the primary side or the high voltage side, connecting it into a star, what will be the nature of the induced EMFs and how they will lie or how they will be oriented? They will be oriented like this. This is A2, A1, this side and this side are parallel. This is C1, C2, this side and this side are parallel. This is B1, B2, this side and this side are parallel. This is before connecting the low voltage side. Okay, so here the direction of phasors are from this point to this in this direction for A phase, from this point to in this direction for B phase, and from this point to in this direction for C phase. Okay. Now, how to make this YY6, that means 180-degree phase shift? So in that case, we have to reverse the direction of all the phases, which means we have to make the direction of this phasor in this way. So it becomes A1, A2,
Water
it becomes image. Sorry,
water image.
Yes, this becomes B2, sorry, B1, and this one will be C2, C1. So how we can do that? We have to do that by reversing the connection. Previously, we have shorted all the 1 terminals. Now we have to short all the 2 terminals in the secondary side. Okay, so let us see. So this is now the reference. Now if we consider the phasor V B2 C2 directed along this direction, then this phasor must be directed in this direction, then it will make 180-degree phase. Okay, and this point will be B1, this point will be C1, and this point will be A1. Let us see. So this is B1, so we have reversed the direction of the phasor B2 B1, similarly C2 C1 and A2 A1. So all the 2 points are shorted here. Okay, so here we can see the phase angle between V A2 B2 and V small A1 B1. I mean this phase, this line. If we consider the direction of this phasor from B2 to B1, so this will be from B1 to A1 in this direction, so that they are opposite in direction. That means phase angle is 180-degree. Okay, so in this way you have to draw the YY6 phasor diagram. Now, based on this phasor diagram, you will be able to draw the connection diagram. The primary connection remains same. So first of all, you will be given 6 coils. Primary connection is all the 1 terminals are shorted and the input terminals are A2, B2, C2. And the secondary side, all the 2 terminals are shorted. So here these 2 terminals A2, B2, C2 are shorted, and these are the input terminals. And in case of low voltage side, now the output terminals are A1, B1 and C1, and these are the output terminals and the neutral point. Is it clear?
Yes, sir.
Any question? So first of all, you have to draw the phasor diagram. Then from that, you have to draw the connection diagram. So YY0 and YY6 both are clear, I think.
Sir, in YY0, what was the phase difference between VAB and VAB? Capital AB is smaller
Zero.
B.
Zero means what?
They're in same phase.
Yes, 0 degree phase angle difference. That means same phase. In case of YY6, now you can draw the clock here. So this is the minute hand and this is the hour hand. Okay, so this is 12, 1, 2, 3, this is 6. Okay. So YY6 means the minute hand will always lie at 12 hours and the hour hand will lie at 6 hours. Okay, so this angle is 180 degree. So therefore phase angle will be 180 degree for YY6 connection. Is it clear or not? These two are the simplest connections.
Yes, sir.
Yes, sir.
Okay. So next let us consider DD0 and DD6. So now we have to draw the delta connection. Again, these three vertices are fixed A2, B2, C2, but we have to identify the phases for delta connection. We cannot say this is A phase, this is B phase and this is C phase. We have two options. See, if it is A1 terminal, then only this will be A phase. But if it is A1 terminal, then this can also be A phase. Okay. So first of all, we have to fix the three vertices, then we have to fix the phases, then we have to draw the secondary side. So for DD0 connection, let us draw the imaginary star for this delta connection. Then since the phase angle is 0, so let us assume that this point, that is B2 point, will be same as that of low voltage side B2 point because the polarities are same, and this is A2 and this is C2. Okay. Now if we take this one as B phase, which means this one will be B1, similarly we will be uh, able to fix or identify this one as the B phase of low voltage side and this one will be small b1 terminal. Okay, so let us identify all the phases. So here this one is A phase, so this one will be A1 terminal, that means A1 and B2 are shorted, and same way we have to identify we have to mark this phase as the low voltage side A phase because these two phases are wounded on the same limb, so they must lie or they must have 0 degree phase angle. So phase voltage, this phase and this phase will be parallel. Similarly, if we identify B phase, so this is our B phase and here we will have B phase and this terminal is B1 as this terminal was capital B1. Same for C phase. So this is C1, C2 and this is C phase. This will be same for the low voltage side also. So this is the phasor diagram for DD0 connection. Okay. Now from this phasor diagram we can identify or we can see that A1, B2 terminals are shorted, C1, A2 terminals are shorted, B1, C2 terminals are shorted, and that is also same for the high voltage side. So based on this phasor diagram we can draw the connection diagram. Here also we will have 6 coils. So here A1, B2, see A1, B2, this connection, B1, C2, this vertex, B1 C2 and next C1 A2, this connection, and these are the input terminals for high voltage side. Similarly, we will have low voltage side connection and the output terminals. Is it clear? Anyone having any doubt?
Sir, here neutral line will be.
Actually, this is imaginary neutral. In case of delta, we don't have any neutral. This
Yes.
dotted line, this is the equivalent star, which will be having some neutral. Okay. Here, in case of delta connection, we are connecting the three windings in as a closed circuit, so we don't have any common point. That is the neutral point. So this neutral does not exist physically. This is imaginary. This star connection, which is shown by dotted line, that is imaginary equivalent star of this delta connection. Okay.
Yes, sir.
Any other question? Okay, now can you draw DD6 by yourself? This is first step.
Sir, in DD0, the condition will be like the phase difference condition.
Phase angle between line EMFs is equal to 0 as that of previous one. That means V A2 B2. This EMF, this line, this EMF will be in same phase with V small A2 B2. This line. In case of delta, the phase voltage and line voltage are basically same, isn't it?
Yes, sir.
So here V capital A2 B2 will be in phase with V small A2 B2, and this line is parallel with this line. This line is parallel with this line. These are phase voltages as well as line voltages.
Yes, sir.
Okay, now can you draw DD6?
Yes, sir. Sir, water image and connections reversed.
So draw and show me. Turn on your camera and show me.
Just a minute. Can I drop in the chat box?
No, you turn on your camera and show.
To join. Sir, just a minute.
No, some problem is there. Anyone else?
Sir, I have done. Can I post in the
Yes,
chat box?
yes. No, turn
Yes,
on
sir.
your camera and show me.
Sir, actually,
That
I'm
will
doing in laptop.
okay. Actually, yes. Post it here.
I posted, sir.
No, not at all. You are not getting. Anyone else want to show something?
Sir, I'm turning on the camera.
Okay, show me.
I don't think it is visible. Wait, sir, give me some time.
No, this one and whoever has shown at the very beginning is same. These two are same. You are making the same mistake. Show me once again. Now it is okay. No, some markings are wrong, I think. Okay, let me show you. When you reverse the polarity, see this point and this point are having same polarity. Okay, so you have to reverse the polarity. That means you have to draw the phasors in opposite direction. See, in case of high voltage side, the phasors are directed from left to right, but in case of low voltage side, phasors are directed from right to left. Okay, so how to do that? You have to reverse the connection. That means if this is B2, then this has to be B1. Okay, so this is B1, this is A1, opposite to that of this phase, and this is C1. They are parallel, that is correct, but they are also opposite in direction, isn't it?
Yes, sir.
Got my point?
Yes, sir,
Yes, sir.
understood.
Yes, sir.
So now you have to identify the phases and the terminals. So since this is A2 and this point will be A1, so here this one is A1, so here it will be A2. In this way you have to identify all the terminals. Okay, so identify all the terminals and phases. See this. So this is B phase, this is B phase, but these two phases are opposite in direction. Here the in case of high voltage side, the phasor is directed from B1 to B2, but in case of low voltage side, it is directed from B2 to B1. Okay, then it will be the mirror image. Now based on this, we can draw. Now see here, if we draw the imaginary star, then this line will be a VAN or V2N. Now here this is VC1N, sorry, A1, because they are opposite in direction. Okay, so now draw the phasor connection diagram. So the high voltage side remains same, low voltage side, compare this connection with the previous one, DD0, A2B1, B2C1, C2A1, and the outputs are 1 terminals. So A1, B1, C1. Now compare this connection diagram with the previous one. It was A1, B2, B1, C2, and C1, E2. In this way, they were connected, isn't it?
Yes, sir.
So how to reverse the phasors, that is clear or not?
Yes, sir. Clear.
Okay, next is YD1 and YD11. Okay, so YD1, so this is Y connection, high voltage side, this we know. So this phase is A phase, this is B phase, this is C phase, no problem with this. Okay, now first of all try to draw YD0. Is it possible or not? Check it. Can you draw YD0 or YD6? Is it possible to draw YD0 or YD6?
Sir, YD0 is not possible, I think, because in
Sir,
star
YD0 is
delta there
possible, I
is
think.
always be a phase difference. So zero
And that is
can
also true for YD6. So YD0 and YD6 are not possible. Both are not possible, right? So if we make this connection as YD, that means star delta or delta star, there has to be certain phase angle difference between the EMFs. Okay, so in case of star connection, this is the reference line. So for delta connection, let us draw that reference line. So this is the reference line. That means this line and this line are same line. They are lying along the same line. Okay. So with this reference line, this delta EMF will make how much angle? 30 degree. And one means lagging or leading?
Lagging.
Lagging. So minus 30 degree. So it has to make minus 30 degree here. Okay. So let us see. So this is now the C2B2 phasor. That means if we consider this line as V B2 C2, so this line will be V small b2 C2, which is making an angle of 30 degree with this reference line or this EMF, whatever we can say, because this V B2 C2 lie along this line. Okay, so making an angle with this reference line or this line are same. This line EMF, both are same. Okay, so that is minus 30 degree. That means this phasor V B2C2 lags V capital V2C2 by an angle of 30 degree. Is it clear up to this?
explain again, sir.
See here, take this V B2C2 as the reference line. So though this is a star connected high voltage side. So what are the line voltages? V A2 B2, V B2 C2, V C2 A2. These are the three line voltages, this one, and this one for high voltage side. Okay. Now we know that in case of three-phase transformer, there may or may not be phase angle difference between line EMFs, not the phase EMFs. Phase EMFs are always lie along the same line. That means there will be 0 degree phase displacement. Okay. Only line EMFs may or may not have phase angle difference. In case of YD1, there is 30 degree phase angle displacement. We call this as minus 30. Okay, this we know. So how to make that 30 degree? We have to take one line EMF and we have to draw the equivalent line EMF making an angle of 30 degree. So here we are considering VB2C2 as the reference line EMF, and we have to draw V small b2C2 making 30 degree minus 30 degree with this reference phasor. Now it is clear?
Yes, sir.
Angle between this one and this one is 30 degree, minus 30 degree. Okay, so that is why this line is drawn here. So this is B2 and this is C2, right? And also see, this line is in parallel with this line. That means if this is B phase, then this has to be small b phase. Phase voltages are always parallel to each other because they are having 0 degree phase displacement. So now we have to draw the other two phases, keeping them parallel to the high voltage phases. That means we have to draw this one line which will be small a phase, that means low voltage a phase, and which will be parallel to this capital A phase. Then where to draw? Here only, right? And this will be our C phase. We have to draw it here only, isn't it?
Yes, sir.
So draw the other two phases. So this point is A2, C. This point is C2, already fixed. So this has to be our A phase. This has to be our C phase. So once we have identified all the phases, we can identify the other terminals also. So this terminal will be A1. Similarly, this one will be B1. This one will be C1. So identify the other terminals and phases. Clear?
Yes, sir.
Yes, sir.
Now we can check all the three line EMFs of low voltage side are lagging all the three line EMFs of, corresponding line EMFs of high voltage side. You can check for VA2B2. This is one, sorry. This is one line EMF. So corresponding line EMF, this one, draw it here. So this angle is 30 degree, isn't it? This angle is 30 degree, and this angle, this phasor is lagging this phasor by an angle of 30 degree. Got my point?
Yes, sir.
Okay, now can you draw YD11? making a positive 30-degree phase angle displacement. Now, first of all, let us see the connection diagram. That is very easy after drawing this phasor diagram. So, short all the 1 terminals in case of high voltage side, show the output terminals and the neutral wire, and in case of low voltage side, draw A1, B2, B1, C2 and C1, A2, and the output terminals are all the 2 terminals. That's it. Okay. Now, can you draw YD11? Y remains same. How to draw YD11?
Sir, YD1 secondary may be translated anti-clockwise by 60 degree.
That's all, nothing else.
So, no.
No, that is not all.
Okay, sir.
You have to do some other applications.
Okay, sir.
Okay, let me show you the reference line.
Sir, I've solved the phasor diagram.
Okay, you have drawn. Okay, show me.
Yes, sir. Sir, I've not named all of them, but I've named some.
Just show me the structure. Concept is okay, but again some mistakes are there. Okay, let me show you. Okay, so this is the reference line. That means this line and this line are on the same line. So C2, B2. Now this angle is how much? 30 degree. So if we draw here, it will make 30 degree angle with this phasor. Now where to draw this A phase? So this will be our B phase and this will be our A phase. So this line and this line are parallel. This line and this line are parallel. Now identify the difference with the previous one. Previously this phase was B phase and this phase here we have drawn the C phase. Okay. Now the position of B and C phase has changed. Okay. So identify all the phases. So this one is now C phase. So this terminal is actually C2 B2. Okay. And this is our C phase. This is our A phase. And this is B phase. Okay. Now compare this phasor diagram with the previous one. Previous one was like this. This was our B phase, this was our A phase, this was C phase. B2, C2, A2. Okay. C2, this was B1, A1, C1. Now see the connection. Here B2 C1 will be connected, but it was C2 B1. Okay. In this way you have to think how to make these phase angles. Okay, so once you draw this phasor diagram, you will be able to draw the connection diagram. 6 coils are there. Primary connection remains same. Secondary connection, now A2 B1, B2 C1 and C2 A1 are connected, and the output terminals are all the 2 terminals. Okay, any confusion?
Sir, why did the phasor here go from B2 to C2, not from C2 to B2?
B2 to
Sir, phasor in this diagram, phasor is going from B2 to C2. Why it is not going from C2 to B2?
C. While denoting the line EMFs, we normally follow this notation VA2 B2, V B2 C2. Okay, corresponding low voltage EMFs are VA2 B2, V B2 C2. Okay, so here we have to consider this line EMFs from B2 to C2, this line. Okay, right? This one. So here same notation V B2 C2. So if you draw it here, then this angle will be 30 degree. So this is B2 and sorry C2, and this is small b2. Okay, so this angle is, that is this EMF is ahead of this EMF by an angle of 30 degree. Clear?
Yes, sir.
Okay. Okay, today up to this, time is over.
Sir, give me 2 minutes to draw that circuit.
It is already recorded. You can go through the recordings now. Okay, I
Sir,
will
please
give you
share
2 minutes.
share the PDF as well.